All right, this is a video on solving rational equations. A real quick review: whenever we've had what's called a proportion, a fraction equal to a fraction, we could use the cross multiplication strategy to help us get rid of both denominators of the fractions. Now again, this only works for a fraction equal to a fraction, called a proportion. So what we did here with the cross multiplication is we would multiply the numerator on the left times the denominator on the right, and that would be equal to the denominator on the left times the numerator on the right. Now, why does this strategy work? Well, if I was trying to get rid of the denominators in kind of an old school way, I would multiply both sides by 3 to get rid of the 3 on the left side, and I would multiply both sides by 4 to get rid of the 4 on the right side. These would cancel, and these would cancel, and I'd be left with 4 times 2 is equal to x times 3, or 3 times x. And that's the same thing we have right here after cross multiplication. So cross multiplication is not a trick. It's not a magic fancy move that we can make. We're not creating anything. We're just skipping a step because we could see by getting rid of both denominators at the same time, it saves us some time. So we're going to use that same idea of cross multiplication to help us solve, but with polynomials expressions. So our first example we're going to try is right here, and these are some of the examples from your packet that we've given you. All right, so what I'm going to use here is that same cross multiplication strategy. 5 times 2x plus 1 is equal to 4 times 4x minus 4. Again, we did the numerator on the left times the denominator on the right, and the denominator on the left times the numerator on the right. Go ahead and distribute, and I've got 10x plus 5 is equal to 16x minus 16. Now I want to get all the x's on the same side and all the constants on the other side. So I'm going to start with my x's, and I'm going to send my x's toward the side that has the most x's. You don't have to do it like that, but I like to keep my x's positive. So I'll subtract 10x from both sides. It's going to leave me with 5 equal to 6x minus 16. Now I'm going to add 16 in order to isolate my variable. 21 is equal to 6x, and my last step will be to divide by 6 in order to get x by itself, and x is going to be equal to 21 over 6, or if you can tell that they both 21 and 6 have a common factor of 3, that would be 7 over 2, or 3.5 is my x value. Okay, so what I'm now going to do is take the example challenge to another level, but we're going to continue to use the same idea of cross multiplication. So my next example is right here, where I've got an expression on both sides. I'm going to end up with a quadratic equal to a quadratic, and we'll just navigate how this is going to work. So x minus 5 times x minus 5 is going to be equal to x minus 8 times x plus 1. And again, this is a double distribution. Some of you guys use FOIL for first or outer inner last. But again, you're multiplying everything in each binomial by the second binomial. So x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. On my right side, x times x is x squared. X times 1 is 1x. Negative 8 times x is negative 8x. And negative 8 times 1 is negative 8. Now I'm looking to combine like terms as much as I can. X squared minus 10x, negative 5x and negative 5x are the only like terms. Plus 25 is equal to x squared. And my only like terms are 1x and negative 8x, which is negative 7x minus 8. And now my goal again is to get everything on the same side, but keeping in mind that to solve a quadratic, we set the entire thing equal to 0, not like the linear that I did in the previous example where I isolated the x's and everything else away from it. When we solve a quadratic, we need to get everything on the same side, and then from there we can either factor or use quadratic formula or one of our other quadratic equation solving strategies. All right, so I'm going to subtract x squared from both sides. Now, something really neat happens here is these cancel, and now I'm left with a linear equation, which is a little bit easier than the quadratic that I would have had to deal with. So I'm going to continue to try to get my x's with my x's now. So I could change strategies now that I've gotten rid of the quadratic term. So I'm going to add 7x to both sides. And I've got negative 3x plus 25 is equal to negative 8. Subtract 25 from both sides. Negative 3x is equal to negative 33. So now, in order to get x by itself, I divide both sides by negative 3. X is equal to 11. Now, again, we find out here that I had one unique solution because my quadratics terms canceled out when I subtracted them from both sides, keeping in mind that if you graph this, you would end up with a bounce at 11 on the x-axis, or a double root. Okay, another example, just to give us a different look, is here. Now notice I'm not quite ready to cross multiply because I don't have a fraction equals a fraction. I need to get a common denominator over on the left side in order to be able to combine like terms. Another strategy that I would recommend is to find a common denominator for all three of these terms. All three of these denominators, I should say. So if I can find a combinator between all three, then it makes it a little bit easier to get rid of the denominators all at once, like I'd like to do with my previous strategies that I've used. All right, so a like denominator between 4x and 2x would be 4x. Because if I multiplied 4 times x, I would get 4x. And I could get to 4x by just multiplying by 2, because that would be a common multiple of 2x. So 4x would be my common denominator. So then, watch what I'm going to do with this common denominator. I'm going to multiply everything by that denominator in order to get rid of the denominators in general. So that's going to be 3 minus 4 minus 1 over x equals 1 over 2x. Now I'm going to take this 4x over 4x here, and I'm multiplying everything by that denominator. I'm sorry, I misspoke. Let me try this one more time. I'm just going to multiply by the denominator and do some canceling. So this is going to be multiplied by 4x, this is going to be multiplied by 4x, and this is going to be multiplied by 4x. So let me show you what I mean with some canceling. The 4's here cancel, and I'm only left with an x, so 3x. The x's here cancel, and I'm only left with a negative 4, 1 times 4, and that's going to be equal to the 2 and the 4 reduced to 2 over 1, and then my x's cancel out. So then I'm only left with 2 there. So by multiplying by the common denominator, I made sure I got rid of all fractions, and I took away that difficulty level of dealing with a fraction. So the challenge here is, once you find that common denominator, either by multiplying or finding the least common multiple, then what you can do is make this now a one-story equation or a non-rational equation. So now I'm just going to solve this with our linear strategy. So I add 4 to both sides to get that away from the x. 3x is equal to 6. And now I just divide everything by 3. X is equal to 2. And that's how I can solve one of my rational equations that looks like that with multiple parts, not in a proportion.